Good morning, everyone. Good morning. Thank you for Blue Water Cruising Association for hosting this event. The first slide we saw here was the DC Conceptual Overview. We talked about chargers. We talked about alternators. We talked about solar controllers. We talked about fuel cells. We talked about an inverter. And I talked a little bit about bilge pumps. Bilge pumps would be right here on this fuse block. Right? This fuse block right here is basically unswitched distribution. That could be bilge pumps, carbon monoxide detector, radio memory, right? Things that always need to be on your boat. So that even if you turn this battery switch off, those circuits are still going to be powered and energized. So now the next thing we're going to talk about is the last two elements on this slide, and they are a battery combiner and a battery isolator. And this can cause a lot of good or a lot of bad, and either of them, okay? And we're going to go talk about that. That is where there's a lot of magic on boats nowadays, where you turn off the battery switch and your panel's energized. It'd be like holding your faucet in your hand. It's not connected to any pipes, and you open the faucet and water's coming down. If that doesn't freak you out, that's sort of a horror movie story, right? I mean, like the TV's plugged on the wall and it's on. Like, how the hell can something be energized if it's not powered? And generally, the reason, and we're going to be talking about all the gotchas, is that generally the reason is because of this little device right here. Probably 90% of all boats that have them have it badly installed. And when things are working, because most people never turn their battery switch off, they leave it on. Most people don't even know where it is. It's there, but they don't know. It's something. And then you turn that off, and then you start seeing a bunch of things on the panel. Your panel's still energized, your water pump is working, and your battery switch is off. That's when you lose hope in your boat. And we're going to be talking about this device next, which is a battery combiner. So battery combiner is right here. Battery combiners have different names from different manufacturers. Blue Seas call them, for example, an automatic combiner relay. BP calls it a voltage sense relay. Xantrax calls it an echo charge. They all have different marketing names, but at the end of the day, they're battery combiners. By the way, if you think you don't have one in your boat, you probably do. You just don't know you do. They're very, very popular. Any boat that has any electrical system or work done in the last 15 years probably has a battery combiner on their boat. Okay? So they're very, very popular. What is the purpose of a battery combiner? And here's a picture of what a battery combiner does. It's right here in the middle. And I want to emphasize here in this diagram, notice that I'm for the first time showing bidirectional arrows. Right? Now, I want to remind people that wires don't have direction. Right? A wire is like a pipe. Water can flow left or right. There's no direction in a pipe, unless you have a gate valve. Right? Battery combiners are inherently, most of them, there's exception to every rule, but 98% of them are bidirectional devices, okay? Maybe 90%, but on boats, probably 98%. This device is a device that effectively replaces you as an operator of, think about all these boats in the past where we would go from off, one, both, / all, and two, right? Pretty commonplace. Instead of having people manually turn a switch on or off, right? They would use this device that would automatically combine the batteries automatically whenever they would sense a charging voltage. Meaning, in the time of plenty, when things are good, it's easy to be generous. I'm always thinking about Bill Gates. It's easy to give 50 billion away when you've got 55. Let's be honest, he's still got 5. I mean, he's going to be all right. You can't spend 5 billion at his age. He gave 50, yes. But it's land of plenty. It's way harder to be generous when you almost have nothing, right? This device acts like a wealthy person. It says, you know what, I got a lot of money, let me be generous. But as soon as the battery voltage drops to 12.8, meaning no more land of plenty, i.e. there's no charging voltage, everyone's on their own, right? It separates the battery automatically. So it puts them in parallel whenever there's a charging voltage. And as soon as there's no more charging voltage, it says, you know what? You're on your own. I got to take care of myself first. Okay? Now, there is no direction to this device. Meaning the engine battery, for example, in this instance, the alternator charges this battery. The moment this battery gets to 13.3 volts, this device senses 13.3 on this post, says, okay, I got 13.3, good, let it out, and then it's going to run through the unswitched distribution to the house battery. And so basically, the alternator, and we had that question before, the alternator is not going to only recharge the engine battery, but it will also recharge the house battery through a battery combiner. Okay? That's how a battery combiner works. It's basically a digital solenoid. It's a relay. It's a device that basically automatically lifts and closes a drawbridge. That's all it is. Okay? That's a battery combiner. Parallel, combine, all the same. 13.3, disconnect at 12.8. This is very important. And it's great because some of us, let's say for example, a lot of my clients, well not a lot, but some of them are airline pilots. Now if you're an airline pilot and you don't understand rituals and drills, you're in the wrong business. Okay? I'd be very worried if you don't have a really good memory and you don't know drills. Like honestly, and most of them end up flying 747s and all these big planes. So those guys I'm really not worried about. And gals, I'm like, drills for you, it's innate. If you're not good with drills, it's like being in the Navy and not knowing drills, you're screwed. Find another job. Like drills is everything it is. Drill, 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 and they never make, and for them it's easy. But for the rest of us, when I get to a destination, I sometimes forget to put my battery switch back to 1 because I get to a next station and maybe there's a friend there, there's something exciting, I'm distracted, the weather's beautiful, I want to go swimming. There's a million reasons to be not thinking about your electrical system when you're boating, right? It's not necessarily top of mind all the time. And that's the challenge with using your battery switch because the problem is you're inherently part of the system. And back to my example of Beneteau and Jeannot, they don't even have a combined mode on those boats. They don't. They're like, people can't be trusted. They just can't. They're going to forget. They're going to not remember. There is no ability to put your battery bank in parallel if you own one of those boats. None. You can't. You can't do it. If one fails, you got to get jumper cables. They can't do it. And they're right. People are the problem. Electrical systems are not a problem. They're deterministic. The operators of the system are the problem. And so we're a huge proponent of removing people from daily critical tasks that, if forgotten, means the next morning you're not able to start your boat. Because some days you don't start your boat because you want to, you start your boat because you need to. I remind people all the time, boating, 99 days of bliss, 1 day of sheer terror. If you haven't had the day of sheer terror, just wait. Just wait. Just wait. And certain times you got to start that engine now. Not in 20 minutes, not in an hour. You don't have 5 hours. The winds are blowing, you're dragging anchor, someone's coming down on you, and you got to go now. Now. It's sort of like your own version of a tsunami. And it's happening and it's real. And it's all, things are not. This is the opposite of what we think about boating. And a battery combiner allows you to not be part of that system. Okay?
Will it ever stop working?
I've never seen one fail ever. Question, have I ever seen a battery combiner fail? Never. Not once. We've installed thousands of these devices. Thousands upon thousands. Now, if they're badly installed, the device doesn't fail, the fuses fails because people don't understand the implications. But the device itself, I've never seen a battery combiner itself use. I've seen bad installations of them. The combiner was fine. It's just they were inappropriately fused. Okay? So when you buy one of these devices, and you might put in, and like for example, Hunter for years would have a single alternator, single inverter charger. They had aft thruster, forward thruster, generator battery, engine battery, house battery. 5 battery banks on a boat, right? Not uncommon on a 50-foot Hunter. Not uncommon, worked on dozens. 1 inverter charger, single output, 1 alternator, single output. How does 1 income stream go to 5 places? How? Battery combiners, right? That's how it does. Otherwise, they need to have 5 alternators, or they need to have a battery charger with 5 outputs, right? How are they going to recharge 5 battery banks if they only have 1 alternator, 1 inverter charger with a single output? They do that with battery combiners. You can buy them in different sizes, 55 amps, 120 amps, 300 amps. You can have them you can also then end up having them be remotely activated. Super common now, super common even with lithium installs, where you actually are able to actually activate them remotely. You can even have a third-party control logic activate it for different reasons. Or you can have it right at the dash. It's actually really popular now. You'll actually have them at the dashes and you can say, I want force combine. I know there's not a charging voltage right now, and you only automatically do it when there's a charge voltage, but for whatever reason right now, I need power with my engine battery. I need all hands on deck. And you can actually do it at the dash. So it allows you to have a manual combine forced over a little control wire somewhere, maybe on the bridge, somewhere maybe in the cabin. And then you basically force a combine. And it shows a big red light and kind of tells you that you shouldn't be like that, and then you can disable it. I talked about different companies. There are directional ones now, but honestly, other than the EcoCharge, I've never seen a directional battery combiner in the field, ever. They do exist, it's not part of their toolkit. They just don't get it. Although there's good reasons for doing it. It's very rare. Now, all that sounds great. Here's another one. That's a magnetic lash ACR. That's a big version, 300 amp. The big problem with this is that when you have different type of battery bank sizes and your battery banks are uneven. Think about hydroelectric dams. The higher the difference between one body of water and the other, the more power you get, right? That's what it is. I mean, that's where they're building. They're not building dams with a 1 foot differential. It doesn't matter how big the water is on the other side. If it's only 1 foot, that's not a lot of power. But when you've got 300 feet, 400 feet of differential, that's a lot of power. So when you've got one battery bank that is, let's say, a thruster battery bank that is at 10 volts because you've been killing this thing, docking the boat, and then you're just hammering the battery, putting a thruster load, and suddenly the combiner kicks in and you've got a large battery bank that's at 13, 14 volts because it was running on the alternator, and you have a difference of 4 volts between a massive battery bank and a thruster bank that's now being hammered by a thruster drawing 300, 400 amps of thruster loads. What generally happens is the fuses that are meant to protect this device will blow because you're going to have crazy amount of current. I've seen 500, 600 amps going through wiring because the differential between the two is so substantial that one bank, which is higher, is dumping everything because it's all hands on deck. All hands on deck means you're supporting the other battery bank. You're trying to equal it out. So if this battery bank is tiny and it's got a huge load and this battery bank's big, as they're putting themselves together and they're trying to even themselves out, quickly there's going to be a massive inrush of current that's going to go through. And the problem with that is the fuses blow. But remember, this is not Star Trek. There's not little computers on every fuse telling you when they blow. You don't know that it blew. And if you're not thinking and you don't have a voltmeter on your thruster battery bank, you don't know that you lost your battery bank, the charging voltage, and eventually the thruster stops working, and then you realize that something's broken and you think it's the thruster, but it's the battery bank, and the battery bank is dead because it didn't get a charge for the last 2 months, 3 months, and now it's done, and then you got to replace that battery bank. And so there are issues with battery combining, especially when the battery banks are big and or they're connected to thrusters. We use them, but not in every application. It's probably the most popular hammer in an electrician's toolkit, but it's overused. Not everything needs a hammer. There's way too many of these things installed. People just don't get it. They don't read the data sheet. They're not field engineers. They don't understand the implications of their choice. And so we commonly are called out for service calls, troubleshooting an ACR. The ACR is not broken, never is. Never seen one fail. But it's badly installed and they don't understand the implications of what they're doing. And then people lose battery banks because of it, because then they lose their charging voltage and nobody knows that they lost their charging voltage because they don't even know to check. So if you have a battery bank for windlass up front and you have an ACR, same thing, absolutely. So ACRs are good, but they're also very bad because you need to be able to confirm the behavior that you want, right? And it gets problematic. So it has its application, but it's not the perfect solution. You know how there's not a single tool that solves all problems? This is an overused tool for too many problems. And on a lot of boats, it causes a lot of grief. We use them, absolutely. If we put thousands, we'll put in a year over 1,000, 2,000, but we're not going to put them everywhere for everything. Question is, if you've got a high output alternator right here, and you've got your high output alternator going to your engine battery, Does it make sense to have an high output alternator going to an engine battery? Context, does your engine battery really need a lot of a charge? Especially going through a battery combiner when really the one that needs most of the charge is going to be your house battery, which is over here. You're absolutely right. It doesn't. And that's a great point. On my boat, most boats I get to play on, and thank you everyone that are in the room that allowed me to play on your boats, I don't do this. No, absolutely not. I'll have an alternator go directly to the house battery, and I'll have the house battery go back to the engine battery. Yeah, because on my boat, I did it like that too. And very good question, Rob. On my boat, the alternator goes to my house battery, because what needs the most amount of power? Who's the hungriest? I mean, is it the teenage kid in your house or your great-grandfather? I mean, this battery here has limited appetite. It can't. I mean, it's going to have like a couple amps. It's fine. This thing could be, my God, it's like a 14-year-old like on a growth spurt playing football. Like this thing could eat so much, and this thing is going to be like, yeah, I'm good. It nibbles and it's done. So alternators, generally high output alternators, we always wire to house batteries. But there's going to be on the next thing, we're going to talk about battery isolators. And we're going to talk about that. Battery isolators are pretty miraculous devices. Any other questions on battery combiners? Question was, I changed my alternator recently from a 50 amp to 100 amp alternator. I've got a battery combiner on my boat. Should I look at that too? Answer the own question, and he said yes, suggested, and he wondering if I agree. 100% agree. Yes, and that's the big thing. I mean, listen, if boating, I tell this all the time, if boating was easy and it was like playing golf and everyone would do a hole-in-one every time we play golf, nobody would play, okay? The only reason my father is obsessed about golf and plays every day in light of his back hurting is because he is obsessed at being better at golf. And boating is like golf. If you want to hit every time a birdie or a hole-in-one, you are in the wrong sport. It is a humbling activity, and if you think it's easy, you will be disappointed. And if you don't know the errors you're making, you will find out later at the least opportune time. So always wonder, always ask yourself, I'm doing this. And if you don't know, ask. Ask friends, ask people on the blogs, ask technicians that work on your boat. It doesn't matter, but ask. Assumptions on boats? No good. World of hurt. World of hurt. Yes, other question. Battery combiners have pitfalls, right, as I brought about. And a battery switch, turning it on and off, has pitfalls. Which one is better? Do you trust a device or do you trust yourself? Really good question. For me, it's about using the right device for the right application. I would never use a battery combiner on a thruster application. I wouldn't. I limit my battery combiners for things that make sense. I limit the scope. And it's like bringing a hammer to everything. That's my point. You want battery banks that are sort of similar in size. They're not going to be discharged too unevenly. Like if you've got a small, for example, Grady White or Boston Whaler or boats that have reasonable battery bank sizes. You've got 2 golf carts and a Group 31. Yeah, it's fine because the battery banks are never going to be so uneven, and even if they are, the current possible is limited. So they have to be similar. So again, it's about knowing the details of a product. It's not to say it's a bad product, it's saying that that product does not solve all problems, and no problem does, or no product does. It's overused is my point, but it definitely has its application. I still use it all the time, and on the ones we do, we're foreseeing, and we're like, okay, will we have ever uneven discharge, like huge differences between the battery banks? Are they running a thruster on that battery bank? Then I'm not gonna do it. Like, I'm not saying, I'm not bringing a hammer to every single situation, and that would be my pros and cons of that decision. Go ahead. So the question is, well, what is the solution if we can't use a battery combiner? Is it another switch? There's other devices. There are other devices, like a DC to DC converter, for example, that is rate limited. We do that a lot on their new builds. It's like being a surgeon. You could either have a knife and some needle, and you start going, or you start having different instruments. So the professional is going to understand the different tools that is disposed to make the right solution for the right situation. To me, there is no problem that is unsolved right now. There is a part for everything, and we'll talk about the next one. A switch goes back and saying, oh, there can't work, let's go back to a switch. DC to DC converters solve that problem, no problem, and we use them all the time for thruster applications. It's just that device does not solve thruster problems. I don't want to get too bogged on because we got to keep going. I'm going to talk about the next device unless there's a question on battery combiners. We're good? All right. Now this device makes me happy. You'll see this is one of the devices that takes care of a lot of problems. By the way, Beneteau and Jeannot use those devices all the time. They have for about 10 years. Quietly. People don't notice because people are creatures of habits and they only do what they know. But the French boat builders have solved this problem a long time ago. That's how they share one alternator and multiple battery banks without a combiner. They do it with this device. And this device is perfect. The battery isolator is one of my favorite devices. You have an alternator, comes in, and this device is directional. The batteries never see each other, like a gate valve. So battery isolator, engine battery isolator, house battery. There'll never be more current going on either of those than the alternator can output because these two batteries never see each other. There'll never be nuisance tripping on this fuse or this fuse or this fuse based on the alternator because your alternator output is never going to output more than your alternator says. People say to me, oh, well, my alternator could, I don't know, can my 100 amp alternator output 150? I mean, that's like saying I deposit 100,000 in the bank and can I get 150,000? No, it's not going to happen. You don't get more than what you started. So if you've got a 100 amp alternator, that alternator can never output more than 100 amps, ever. It's never going to happen. Otherwise, it wouldn't be a 100 amp alternator. It'd be a 150 amp alternator or 200 amp or 300 amp. And the great thing about this situation here, this battery isolator, is that because you know the maximum amperage that this device outputs, you can know exactly what fuse you put here, you know exactly what fuse you put here, and now you'll never ever have nuisance tripping. And like I said, this has been in production, Jeannot and Beneteau boats for a really long time. This is how you solve the problem having one alternator go to multiple battery banks. And I cannot emphasize how amazing this device is. In the past, they used to make these devices with diodes. They've been around for 20, 30 years. Bayliners used to do this all the time. They would put a diode combiner in and they would have one alternator going to 3 battery banks. But diode combiners would literally draw 0.7 volts, which is about probably 60 to 70% of your alternator output would be lost for this automation. And Bayliner was like, you know what, it's a good price to pay. I'd rather lose 70% than having operators blame the boat and hate the boat for losing all their batteries. So they don't even put battery combiners on these big 4788s and all the Bayliners. They would all have these sort of blue devices with a bunch of fins on there. They'd be mounted against the ceiling room of the engine room or on the bulkhead. And they would actually have one alternator going to multiple battery banks and the operator wouldn't even be able to do combine. Because they also realized that people are the problem. They did it with diode combiners, but they were paying a 70% cost in loss of efficiency. That's a big deal. I mean, that's some serious taxation. But you know what? It's better than nothing. They're like, what's the alternative? Expecting that our owners are never going to forget? It's ridiculous. And honestly, it doesn't matter what the reason is for you to have a problem on your boat. It's upsetting. And you're not going to blame yourself. You're going to blame the manufacturer. And if you don't blame yourself, someone on the boat is going to blame you. Or the boat. And they're like, that's it. I'm out. Tap out. I'm getting out of this. Let's do something else. A cottage. It's not fun. This is too stressful. Like, it's not good. And so they ended up putting diode combiners. Now, the new ones are 98% efficient. 98. You lose 2 points, 3 points. That's nothing. I mean, we do that with credit card merchant fees all the time. You spend $100 at a merchant, he's only going to get 97. I mean, he's not seeing the whole transaction. People live with that all the time. 2, 3 points for automation, for convenience, no problem. And that's why these FET battery isolators are the bomb. They are incredible. We put them on every boat we get on. They're a relatively new device, and they have low voltage drop. Incredible devices. Combiners are bidirectional. They go from battery to battery. Isolators go from alternator to batteries. See how it's a Y, inverted Y? The batteries can't talk to each other. They have no ability. There's no battery to battery. It's a battery isolator. Think about it. The batteries are isolated. The other one, the batteries are combined. The batteries will never see each other here.
So regardless, you're better to put the battery isolator in.
For an alternator, absolutely 100%. And by the way, a battery charger, like a battery charger, is made of an isolator inside. That's how they get 3 battery banks to never see one another and have one charge rate go to 3 places. And that's also the reason why battery chargers can't have multiple charge profiles. It's because they charge one profile and it hits 3 isolator out. They actually have isolators inside the battery chargers. That's how they do them. We do a company that sells military chargers, actually Isolator Systems. They only have single output chargers. And if you want more outputs, you put one of their devices like this to do multiple battery banks. And they're military grade, like they go on tanks and like real stuff. And great company. And they're like just modular, like single output charger, 100 amp. If you wanted to go to multiple places, get a battery isolator and then spread it out. They actually sell the 3 output charger in 2 pieces. One, the battery charger, single output, and then a battery isolator beneath it. The question is, I've got a generator, shore power, and an alternator. Is there an isolator on each one? The battery charger effectively has an isolator built in it to it. Not the inverter charger, but a battery charger. If it has a multiple output battery charger. Inverter chargers are single output devices, they don't. Battery chargers are powered either by shore power or generator. Alternators are powered by the engine. An alternator, if you want your alternator to go to multiple places, and you don't want to ever have nuisance tripping, and you don't want to worry, you get one of these. Question, should a windlass be powered by the engine or house battery to cranking it up? In this case, because the alternator is going to both batteries directly, the windlass can be at either place because both are getting a charge from the alternator. If your alternator was wired typically to your engine battery, then yes, it'd be better to have your windlass be connected to your engine battery because that's the battery that is connected to your alternator. That's right. When you're running a windlass, like our cars, for example, air conditioning, radio, none of this is running off the battery when we're running our cars. Effectively, your alternator is running those loads. Right? Your battery's not affected. It's only to start. Once the alternator kicks in, the loads are always less than the alternator output is. Like we have a big Sprinter van, and it has like a 200, 300 amp alternator. Why do they do that? It's so that you could run refrigeration, whatever you want in that big van. The alternator will always output more than what the loads in that cargo van will need. So one alternator charging 2 or 3 banks at the same time replaces a diode combiner. And the really big takeaway is there's no paralleling of batteries, right? A battery combiner combines batteries. Parallel and combine are synonymous. They're the same word. And so you can avoid that. And the French builders have been using this for years, to their credit. This is what the old style looked like. This is the diode combiner. And these are heat sinks. The heat sinks were there because this device created so much power loss through the diodes that they needed to be able to dissipate the heat. So alternator would come on here, and then you'd be able to connect 2 batteries. This is a 1 to 3, right? So you can actually have 3 battery banks. So it's hard to see, but that's the input. Output 1, output 2, output 3. So we just did a boat last week. We put 2 of those in on a boat that had a bunch of different battery banks. Windlass, thruster forward, aft, generator. Like we're doing all these different battery bank, house bank. All of those are going on one of those. Okay. The question is, does this replace a combiner or replace it? Well, it depends. For an alternator, it certainly does. Now remember, this device here doesn't do anything for a battery charger. If you have a battery charger connected to your engine battery, this device will not share that voltage, right? This is not doing anything for a battery charger. If you have an inverter charger, this doesn't solve it because your alternator has nothing to do with a battery charger. They're separate. So this is only good for an alternator, right? Battery combiners would be, how do you charge, for example, you've got an engine battery that has a single output charger and you want it to charge another engine battery. Then you would put a battery combiner there. That's why they're not one or the other. They're different devices for different purposes. And if it's confusing, by the way, welcome to the world of electricity. Okay? I mean, if it was easy, none of us would be taking a course. All would be done. The technicians would all get it. All the manufacturers would get it. I wouldn't have a job. I'd be doing something else. And, we wouldn't be here right now.
Are you going to provide?
So the point I talked about, avoid nuisance stripping, and then the cabling and everything, because you know the maximum output that's going to be coming out of that device, it's very predictable. Okay? If you have an alternator and you have multiple battery banks and you want to share the voltage, you get one of these.
I thought the controller did that, obviously.
No, the controller outputs what the maximum output of that device is and what the charge voltage. It doesn't separate to multiple devices. Alternators are single output devices, unless you have a battery isolator. Yeah, well, any boat that has 2 battery banks is going to have a battery isolator in the future. There's no reason. The reason they did in the past, boats didn't have those, is because the diode combiner was taking a 70% cut. And some builders are like, well, that's too expensive. I can't afford that. That makes my alternator so inefficient that I can't do that. I can't afford that. So I'd rather have the owner get 100%, but they're sort of like, by the way, here's another thing too. I emphasize this all the time. Regardless of money, there is no perfect boat. Doesn't matter. You could have 10 billion, you could have 100 billion, you could have $1 trillion. Money does not give a perfect boat. There is no perfect boat. Every boat is compromises. Every single one is a million choices. You do that, you don't have this. You do this, you don't have that. Pros and cons. That's the beauty of a boat. Because otherwise there'd be one owner on earth that would have a perfect boat. And even the billionaires all have different boats. Why? Because there is no perfect boat. Everything is a choice. Do you have 5 decks, 6 decks? Do you have low decks, 1 deck? You have the length. All those come at a cost. Everything is like, even if you can afford to have a big boat, do you want to have all the crew on board? Can have an 80-footer, but do you want to just be you and the missus? Do you want to have guests or no guests? Like, everything is a choice. There is no perfect solution to a boat, regardless of money. Money is not the limiting factor for perfection. It's choices, constantly choices. And an alternator here with a battery isolator is a choice. One of the many choices that designers of electrical systems have to choose. Either you have that on board or you don't and you have a combiner. But there is no silver bullet ever about anything. So a battery isolator, question, a battery isolator and a combiner, do they play similar roles? A battery isolator only really works with an alternator, right? That's what it is. It's an alternator, a way to share an alternator within multiple battery banks. A battery combiner will share everything. It puts batteries together. So it could share solar, it could share inverter charger, it could share a charger, it could share an alternator. There is no distinction as to what creates a charging voltage on a boat. So battery combiners will do everything. Battery isolators will only do alternators. So this gentleman here is talking about their boat where it doesn't sound like they have a battery combiner or an isolators, but they have a lot of parallel switches. And he's saying, it looks like the designer of my system chose the flexibility of having me make decisions at the cost of maybe making my decisions. Because, yeah, that's what it is. And that's why I try to reiterate. It's always, sometimes I tell that people, here's the good news and the bad news. And the good news and the bad news is the same news. It's not two different news. It's like, the good news is you got a lot of choice. The bad news is you got a lot of choice. I tell that all the time when we're talking about navigation systems. The great news is you got a lot of choice. The bad news is you've got a lot of choice. Depends. How do you see it? And you're right. You know, the builders and the designers are making these decisions. What do I anticipate the operator to be? And for example, for Jeannot and Beneteau, they're thinking a lot of my boats are going to go to charter fleets. Charter fleets do not have necessarily very knowledgeable operators, right? And so they're thinking, I need a boat to be reliable. And so the last thing I want to do is having someone needing to dial stuff in on a charter for 7 days in the Caribbean or in the Med, and they're like, screw that. I'm taking the operator out of the equation. Just out. I can't have him make decisions because then his charter is done and then he's going to be upset at the boat. He doesn't care that nobody blames themselves for anything. Everyone's looking at external factors. Everyone's perfect. I'm perfect, therefore the problem is somewhere else. Nobody makes an accident. They always blame someone else, right? How many people are guilty in prison? I mean, it's a ridiculous amount. It's like everyone's a victim. So that's where the designer's sort of thinking like, well, I want to be blamed or not. And it depends on the operator, okay? I can't emphasize how important monitoring is. You got to have on your boat monitoring. Otherwise, you're in a land of magic and surprises. But you can't say that you're disappointed that things are unpredictable or you don't understand. So we talked about battery combiners. We talked about isolators. And notice how this is a bidirectional device and this is a directional device. So when you get an AC or DC voltmeter, people tell me all the time, and we'll talk about a battery monitor just next. They say to me, they say, Jeff, I got a battery monitor, and I've got a battery monitor on my boat. I'm like, oh, you do? You got battery capacity, volts, amps, amp hours? Oh, no, I've got a voltmeter. I'm like, okay, voltmeter. That's good. That's a start. Nothing wrong with that. But I said, do you realize that capacity from voltage is only possible if your batteries have neither been charged or discharged for a 24-hour period? They're like, well, what do you mean? I'm like, oh, yeah, it's like your your at-rest heart rate. No doctor would ever look at your heart rate at any given moment without context and say you're healthy or not. It'd be crazy. My heart rate, I spin twice a day. It's 170, 165, no problem. Am I unhealthy at 165? Well, it depends. What am I doing? It's context driven. The only indication of health is your heart rate when you wake up, because that's something that is at rest. And a battery is the same thing. An at-rest battery voltage is the only one that matters, right? So if you're looking at your battery voltage and you're using it as a nominal sort of absolute number, and you're like, oh my God, my batteries are 11 volts, they're toast. Wait a second, context. If you're sprinting uphill, what should your heart rate be? Should it be 65 or 165? Well, most likely it's going to be 165 if you're sprinting uphill. And so if you're running your inverter and you have a large load on, it's okay for your battery bank voltage to drop to 11.5. Your starter might bring down your battery voltage to 10.5. Does it mean it's a dead battery? No, it means you just applied a 300 amp load on the battery and the battery's having a hard time sustaining it. But as soon as you take away the load, the battery voltage will slowly creep back up. So voltage is only an indication of capacity for DC when, and this is very important, when it's an at-rest voltage, okay? So DC volts indication of capacity for an at-rest battery. And that would apply on our boats really well with engine batteries. Because you stop using an engine, you shouldn't have any loads on it, you come back to that battery 24 hours later, you move the little toggle on your DC panel, you check your battery voltage, and if it says 12.6, 12.8, you got a full battery, right? But you can't do that on your house battery because your house battery is constantly being used. To know what the capacity of your house battery would be when you're actually using your battery, you'd have to say, everyone stop using the battery for 24 hours, let's put it at rest, 24 hours later, let's come and see it, and then let's temperature compensate it, and then we'll know what our battery capacity is. How practical is that? It's the definition of impractical. You can't stop using your boat while on your boat to know the capacity of your battery. Hence, it's sort of a context-only useful thing, but still useful to see changes, right? I.e., you plug into shore power, before you plugged in, you're at 12, suddenly you plug into shore power, you're at 12.8. Oh, increase in voltage, your battery charger kicked in. Or your batteries were at 12.2, you start the alternator and suddenly they're at 13.3. My alternator is working. You're looking for a change, right? You're sort of looking for an effect, a cause and an effect. What made this change? I'm always constantly looking at my alternator output. I don't look at the amps, but I'm like, what's the voltage before I started the alternator? What's the voltage after I started the alternator? If I don't see a rise and it didn't move, I know that my alternator is broken. I do that every single time I start the engine. And honestly, all of us have a voltmeter at the engine panel, and you should be looking at that voltmeter and say, hey, is it rising the moment I started the engine? Because if it didn't rise and it's not higher than when you started the engine, before you started the engine, then you know that your alternator or a connection between your alternator and that battery is broken. The other thing too is that when you've got an AC panel, make sure that your AC volts are actually, a lot of them, if they're wired properly, are going to actually tell you the voltage before you turn on the breaker. As you go to destination marinas, it's very important to realize that those destination marinas were not built understanding or knowing that boats were going to have bigger and bigger electrical systems. I have boaters that come back from not destination marinas, like marinas on Vancouver Island, like really expensive ones. And the dock power is not 240, it's not 220, it's not 200, it's like 190. Right, 190 volts. Because there's so many other big boats at the dock, they're drawing so much power, they can't give the power everywhere. And these are big boats, like a 50-foot boat 50 years ago was the largest boat. I met a client once and his father was the big shot lawyer of the city and he became the mayor and he had the largest boat in the city. It was like 50 feet. 50 feet is not the largest boat in the city now. Okay, it's not. And so there's a lot of boats that are coming to these marinas have huge power consumption. And what's happening is before you plug in and you turn on your breakers, make sure your voltage is high enough, because if your voltage is too low, and I had that happen to a client on a big boat this summer, you'll break stuff. Low voltage means if the appliances are running, can blow. And that's expensive. Those are big bills. They hurt. It's not a couple dollars. It could be tens. And on the bigger the boats, it's hundreds. You can lose a lot of stuff on a boat for low voltage, like really low voltage. So use your voltmeter on your panel, AC meter, before you turn on that double pole breaker and say, is my voltage high enough? I know that I want to connect, but should I? Right? And make sure that it's not 90 volts, like on a 120 volt circuit. The other thing too that people, and I can't emphasize this enough, a lot of times the DC voltmeter is getting voltage at the panel, not at the battery. Okay, this is a really very important key takeaway. It's like taking your heart rate here versus at your heart. There's a difference of your heart rate in two places. You want to go back at the heart, right? At the source. So a lot of times volts at the panel are measuring voltage not at the battery, but at the panel. And therefore, voltage under load is different than voltage at the battery. That's why you could have a battery at 12.8 and the panel might be at 12.4. Right? Because there's voltage drop across that line. So you want, as an owner, you want to know, is my voltmeter actually connected at the battery or is it connected at the panel? 99% or 95% of you are going to have it at the panel. Why? Because it's much easier to run a wire for 1 foot than it is to run a wire for 30 feet. If you're going to go, obviously, analog meters are absolute, well, it's fine, I'm not going to use the word, they're not absolutes. They're not accurate. You're just using them as a sort of a gauge to see about an incremental change. I've seen these to be off by 2 volts. 2 volts. Like, yeah, I mean, you either change them out to digital or you take them and you say, it doesn't matter what the number is, you're looking for either a big change up or a big change down, but the number itself is irrelevant. It's a change indicator more than anything. Do not use it as a nominal indication of your battery capacity. Like I have an analog voltmeter on my engine panel before and I changed it to one of those. It was off by more than 2 volts. Now I knew that, so you sort of do an offset, right? You're like, engine battery could be at 14, it's at 12 at the panel. When it's at 10, it's at 12. You know, like I knew that it was off by 2. And I was always looking, I knew what the offset was and I was always looking for change. And then I put an OLED display, right? Something like that. And now it's super accurate. They're just, I mean, they're cheap. Back in the day, these are still cheap. These are like 20 bucks, 10 bucks. They're not expensive. Yeah, the question is it a good idea to replace analog meters with digital? Yes, but this is inexpensive, but this is very expensive. So it depends on how deep your pockets are and what your pain point is on your boat. This is not $10. This is hundreds of dollars.
Oh, really?
Yeah, so that's the problem. Yeah. Okay, I'm going to talk about battery monitors. Any question on voltmeters? No? Pretty straightforward. The reason why you care, I just want to emphasize why you care about a voltmeter, is that you might not care, but one day you're going to want help from someone. And that someone might be your technician, might be me, whoever it is. And honestly, if you don't have a voltmeter and you have an electrical problem, and you don't have a multimeter on your boat, there's no help to be given. It can't. If I have no feedback, what's your battery voltage? Don't know. Do this? Don't know. Do you have battery? Don't know. Does this work? Don't know. Have you ever changed? Don't know. I mean, I can't walk you down a path if you can't walk. You have no eyesight. You got to give me feedback. Like, is there a path beneath us or not? If there isn't and you can't tell me, then the conversation is, okay, bring the boat back to a place, then your trip ends, and then bring a technician in with a multimeter and then they can solve it. But if you've got good voltmeters on your panels, it's amazing what you can do with very little tools if you know what you're doing. So highly recommend, make sure your voltmeters on your panels are operational and don't care that they don't. So get them fixed before you leave the dock if they don't, so that one day when you're in the middle of nowhere, you can get air support remotely, okay? It's incredible what we can do with a voltmeter on a panel for troubleshooting, alternators, inverter, chargers, all of these different things. It's really powerful.
And you're wiring that directly to the battery thing.
Yeah, and if it's not at the panel, it's something, but it better be at the panel. Yeah. Ideally, I'd rather know what happened at the heart of the battery. If not, then I can play with it. You know, because information is power, right? For troubleshooting. Cause and effect, cause and effect. All right, battery monitors. Battery monitors right here. And I am a huge proponent of battery monitors. I love these devices. They're about anywhere between $225 to $350 Canadian. They're great. What the big thing about what they do is it sort of gives you a fuel gauge for your batteries. And what that means is it tells you how much battery capacity you have in your batteries expressed as a percentage. Anybody can understand a percentage. I'm at 50%, 70%, forget amp hours, forget everything I told you. Anybody can understand what 80% of a battery capacity is, right? I mean, it's pretty easy. And the other thing that's really amazing about them is they also tell you the rate at which you're discharging your batteries. If you have a power boat, you'll have a very idea of correlating speed to cost, right? If you have a power boat, sailboaters don't really know that. But if you're a power boat, trust me, you have a very direct correlation between financial pain and your speed. right? And you know that. You know that. There's no other way around it. You know that at this speed, you're paying a lot. And batteries don't give you feedback. And it's really nice to be able to quantify at that given moment, what are you putting onto the battery? What is your current draw? Because the speed at which you are discharging your battery will directly affect the longevity of your battery, right? If you've got a 100 amp hour battery bank and you're discharging at 20 amps, you know that that's not a lot of time to the 50% mark, right? But if you're discharging at 2 amps, you're like, oh, pretty good. I've got a lot left. Because it's not only where you are when you're driving a boat where your fuel is, it's the rate at which you're going will affect how far you'll be able to get, right? Your range is directly affected by your speed. So if you're fuel burning and you're like max throttle and you're just going full open throttle, your fuel tank will not bring you as far and your range is limited. If you reduce your fuel burn, you'll go farther. And batteries are the same. It's a weighted scale. So battery monitors actually take that into account, and it will take the whole magic of, should we recharge the batteries? Should we stop charging the batteries? Because remember earlier we talked about 85%? How does someone know what 85% is without a battery monitor? There's no way. You couldn't. How? You'd guess. I'm at 85%. How the hell do you feel that? You can't feel that. There's no way. But a battery monitor would tell you, right? And then that's the great thing is not only does it tell you when you should start charging. Remember I told you it's diminishing returns? You shan't go below 50 on a flooded, below 30 on an AGM, below 20 on a lithium or Firefly. Well, that's your floor, but your ceiling is 85 on all those batteries except lithium. The great thing with this is it actually tells you what your bookends are, right? It takes the whole magic out, right? Magic is not good on a boat. You want deterministic. You want to have predictable, knowing where you are. Super, super important. When you're buying one of those, make sure that you can get a battery monitor that expresses battery capacity as a percentage, because every single crew member on that boat is going to get that. You don't need to be an engineer to figure battery percentage, right? And honestly, you know, you can say to everyone at 50%, we got to recharge. At 85%, we stop. It's your bookend. It's, you know, you don't need a big manual. Everyone gets it. And I have a lot of owners where maybe the male counterpart has a little bit of bravado, doesn't care so much, where the wiser one on board is saying, no, you know what, we're not doing this. Like, I'm not losing my fridge in the middle of the night because you don't want to recharge the batteries. Like, we spent X amount of dollars for all this produce, everything in the fridge. It's not going to thaw out over the night. We're going to run the alternator. We're going to do whatever it needs to so that we can spend overnight without actually losing our battery bank. And so then it's not a he said, she said anymore. It's like, oh yeah, we're good for the night. And then you're not, because then that way you've lost all your trust. All your cred is gone. It happens all the time to boaters. Like, are we good for tomorrow? Oh yeah, we're good. And then they're not, and they're like, you burn that bridge is done. Like, there is no coming back from that bridge. Like, it's like, yeah, I'm going to ask you again. Sure, yeah. And then it's like, then you overcompensate. You're always too much charging. This actually takes the whole guesswork out of it. Battery monitors, believe it or not, are actually pretty complicated to install. About 50% of them are not properly installed. And the reason is the shunt is the device that measures all the current going in and out of the battery bank. And oddly enough, and unfortunately, people don't understand that because they don't read the manual. And they believe in shortcuts because they don't read the manual. And they think they're smarter than everyone else because, I mean, that's who we are. And what happens is then you have these battery monitors that are giving these incredible readings. Like, I have owners that come to me and say, Jeff, my fridge doesn't draw any power. It's amazing. It's the most efficient fridge you've ever met. It draws no power. I'm like, well, that's amazing. I am so envious of you. Like, I'm like, that's incredible. Yeah, and my heater too. My heater does not draw any power. I'm like, really? You've got blowers and everything? Yeah, no power at all. Look, you can see on the battery monitor. I'm like, okay, great. Okay, so let's recap. And I tell the guy, I'm like, so why am I here? Yeah, my batteries are draining all the time too fast. I'm like, all right. How could those two be unrelated? I wonder, did you give me all the information? And it's funny because then we laugh and he's like, and we all end up laughing because you know what? That's the thing about boating. It's humbling. I don't care what you do on land. You could be, some of my clients are surgeons. Some of them have 6,000 employees. They're CEOs. You go on a boat, you will be humbled. I don't care. You could be an astronaut. You could be whatever. It doesn't matter. Boat ownership is humbling. And then they're like, Oh, so that's why my batteries are always empty, but my fridge never drained my batteries. I'm like, yes, because they didn't include the fridge in your shunt. Your fridge was going directly to the battery because they wired directly to the battery because it was added later on, and they bypassed the shunt, and so was your heater. And that's why you have a miraculous fridge or miraculous heater that draws no power, but also your batteries were always drained like 3 times as fast as your battery monitor said. And then you come up and you're like, yeah, that happened to me too. And we all laugh about it, but that's what it comes down to, right? So battery monitors, if your battery monitor is doing something better than everyone else's battery monitor, it's not because you're lucky. It's because it's not actually incorporated or it's not calculated. All right, so the shunt is this little device over here. And that device, nothing can bypass it. It's sort of like counting cars on a bridge. You know, if you're going to count cars going on a bridge, you're not going to take just one entry point. You're going to put yourself probably in the middle of the bridge, right? A place where no one can bypass you, right? And the challenge is over time, installers, maybe your shunt was properly installed once, but then the person who installs your heater bypasses it, doesn't know. You change your refrigerator and it's not working well, and the installer doesn't get the panel and it's too complicated. And he's like, you know what, we're going to hardwire it to the battery because it's too complicated. You know, I'm not going to look at the panel. The panels, I don't know what to do. And they bring it right to the battery. And the negative, they put right to the battery. But what they don't realize is they're bypassing this shunt. And most installers on your boat don't know everything about everything. It's not possible. I only know electrical, but that's a small little world. That's my world, but there's a bigger world out there. And so there you're going to have people that are doing heating systems, that are doing refrigeration systems, that are doing downriggers, that are doing stereo systems, and they don't understand what a shunt does, and then they end up bypassing it. And that's how sound systems don't draw power. That's how downriggers don't draw power. That's how refrigerators don't draw power. It's not they don't draw power, it's that you're not measuring it. Okay? There is no magic on a boat. It's just a sign that there's something wrong. So the question is, I have a battery monitor installed on my boat, and the battery monitor is not showing me an increase of charge on my engine battery or my house battery my alternator is running. What happens is, you've got to remember with batteries, there's something called a common negative, right? We hear that word all the time. Common ground, common negative. Your engine battery and your house battery are tied together via a negative cable. Otherwise, they would not be common. Common means actually they're one and the same on the negative. What probably happened is that battery monitor, the negative side coming from the engine battery to the house battery is probably going battery to battery, and it's not going to this. The common cable that's coming from your engine battery, from this cable right here to this one here, would have to go on there. It bypasses the shunt. And that's the issue, is that the shunt is bypassed by the jumper cable that is putting the batteries common.
Because that's an essential feature.
Oh, of
that
course,
I
100%.
obviously wanted to have.
100%, and that's generally an indication. So if something's weird, it's because something's wrong. You know, I've got solar panels. Think about it. You're doing solar panels. It's a great do-it-yourself. Everything is easy until you do it, by the way, right? That's why we, criticize hockey players, right? The net was open, come on. And it's like one of 3,500 kids, plays like hockey, how many hours? It's the same thing. Solar, you're thinking you got a controller, 2 wires, you go right to the battery. You can bring the positive to the battery, but if you bring the negative to the battery, you bypass the shunt, your solar panels will never output. And I get calls all the time. The solar panels don't work. The solar panels don't work. I'm like, are your batteries getting charged? Yeah. Does the voltage go up? Put a blanket on the solar panel. Okay, all right. Measure the voltage. Take the blanket away. Does the voltage increase? Yeah, the voltage increases, but there's no current. I'm like, how do you know? The battery monitor tells me there's no current. Did you bypass the shunt? The shunt? I'm like, yeah, you can't bypass the shunt. What is the shunt? What are you talking about? I connected the battery. I'm like, yeah, but the battery monitor is not a spiritual device that is connected like telekinetic, like the battery says. No, it's like a car counter. Like, think about when they put those little pneumatic sort of like hoses on the road to count cars. This device, if you bypass and you go on the sidewalk, it's not going to count you. Like, it needs to go through the shunt. The shunt has to be a single choke point for everything. So your negative has to be here on the DC distribution.
All your negatives got to go through the shunt.
All of them, every single one, bang on. All the negatives have to go through the DC distribution, which in turn is a single choke point, is your shunt. Effectively, when you have a battery monitor, you only have one cable connected to the DC negative of your battery. It goes to the shunt, from the shunt to your DC distribution, and that's it. Nothing can ever bypass the device. If it does, you'll either have a fridge that doesn't draw power, or you'll have solar panels that never give you power. Or an alternator that doesn't give you power. By the way, all this stuff is hard, and it's humbling, and it's like golf. It's just part of it. You don't get angry about it. You just go, it's a boat. Of course, it can't be easy. I tell that all the time to my team. Nothing's ever easy. Nothing. Until you do it, everything's easy until you do it, and then when you do it, you're like, oh yeah, that was humbling.
So even your solar has to go to that DC.
Everything. There is not a single thing that can bypass the shunt. You bypass the shunt, you don't measure it. You don't measure it, it's not inaccurate. Because if you're missing amps going in or amps going out, then what the hell is your battery monitor for? It's a fraction of what you're doing. You don't want that. Yes? All right, so what that did is they screwed up the polarity of the shunt. They got the wires. So the question was, when I charge my batteries, it's negative, and when I pull, it's positive, right? It's the opposite of what it should be.
It pulls correctly, but I don't.
So hearing what you're saying, that your solar works fine, positive amps, your loads give negative amps, then the polarity of the shunt is fine. To me, if your alternator does negative, it means your alternator doesn't work. You got to replace your alternator. Look into that. I think to me, it's because you've just confirmed the polarity. You can't have polarity right for one and not the other. It's impossible. They're either be all wrong or all right. So it's not the shunt. It might be your alternator. Alternators are not hard to test, by the way. It's not a painful thing. It's not that bad. And they're not that expensive. And in boat bucks, it's not a boat buck.
So basically,
I'm a boater too, I understand. Bring it out of the Dow. Yes, go ahead. If you install a battery monitor and you're installing a shunt, the shunt has to be in line as a choke point for all things that are going in and out of your battery. Yeah, forever. Not just now, but later. So this is an AC panel. And you remember I talked a little bit earlier how important it is to have an amp meter and a voltmeter? It's essential to have a voltmeter, an AC voltmeter, and an amp meter is really going to help. It's disconcerting to realize that I don't care how expensive your boat was. You could buy a $3 million boat. You could buy a $1 million boat. You can buy a $300,000 boat. You can buy a $50,000 boat. All boats have more AC loads than your shore power can run, and or even your generator. Doesn't matter. Everyone has to do load management on a boat, unless you have a really big boat. Like if you have a huge boat, then they'll start a second generator and they'll sync them. But we're in the 125 range. And at this point, you have an engineer on board, and it's a completely different Star Trek, right, level. But like if you're a normal person, the reality is that all of us either have 30 amp shore power, 50 amp, or you can even have a generator. It could be an 8 kilowatt, it could be a 12 kilowatt, it could be whatever you want. Generally, it's very easy for you to overload your generator and or your shore power, especially shore power, because 50 amp goes pretty quickly. And so if you don't have an amp meter on your panel, you're always going to be frustrated. The breaker's going to constantly trip at the dock because you don't know how to manage your loads. You're going to not be able to run your hot water, a water maker, your galley appliances, your garbage compactor. I know it sounds silly, but some boats have that. But even on my boat, I have a 30 amp shore power receptacle, right? 30 amp on a sailboat is pretty usual, right? Up to probably 40, 43, 45 feet. Maybe around 50, they'll have two. But 40 up to 45 on a sailboat, you've got a 30 amp. Hot water tank is going to draw easily 15 amps, maybe up to 20. A heater, like a little ceramic heater, 12 amps. A microwave, 12 amps. Already there, if you've got a hot water tank and you've got a shore power and you've got a heater running, you can't run anything else, otherwise you're going to trip the breaker, right? You got to run loads sequentially. That's on a little boat. And the big boats, I have some clients that have 65 footers. And they've got to run things sequentially too. First they start making water. Maybe then after that, they're going to run their hot water tank, and then they're going to start running chargers, and they're going to add chargers. But you've got to manage your panel. You just have to. It's just part of it. It's just, and if you don't want to manage it, then you're going to pop breakers and you're just going to get frustrated. So get ready to start walking because you're just going to do it. And if you have an amp meter, at least you can start loading them up one at a time. And you go, well, I'm drawing 50 amps. I got 50 amp shore power. I can't draw more than 50. So around 40, 45, you got to start like deciding what are you going to run now until something is done, and then you can start running else. And it's like money, honestly. Money's the same, is a great analogy. You can't do it all at once. We all spread our expenses over time. We're all doing that with money. Power is the same thing like money. Nobody has ever have enough, and you got to sort of manage it slowly at a time because you can't do everything at once. The polarity light we talked about, that's essential, and that is actually this little red light here. If you don't have one on your panel, you should absolutely get one. And it's important because it tells you on some destination marinas, believe it or not, they're actually going to have the polarity wrong. The marine world is sort of a gray world where you don't have to do things professionally, and hence why I have a living. Otherwise, if it was all done right, I mean, I would never repair anything because everything would be done right. And marinas will have, people, anyone wire their marinas in certain places, destination, because they're cost conscious. They can't afford to bring an electrician, nor do they have one. And so they get their sort of general maintenance guy to wire the docks. And you can wire a boat AC and swap the hot and the neutral. And so that's what this light is for, is to tell you that right now the neutral is energized, not the hot. And if you have that on your boat, you're one step away from death. So there's two, it's like, first step would be putting a bullet in the gun. And then the next one is then you roll it and then you pull the trigger. So you're not guaranteed to die, but the next one, if you have another error on your boat, which is a permanent connection between your DC ground and your AC neutral, which house electricians would always do if they wired your boat, because that's what it's like on land. And that's a common error. About 10% of the boats have that. So it's a gun with 10 chambers on it. If you have that error, which is 10% of us do, because most people that wire boats are not professionals and they're just sort of amateurs, and you have reverse polarity, your whole engine block, your sink, your shrouds, your through hulls, everything on your boat is going to be energized with 120 volts. And you can touch your engine block and not get electrocuted because it's like a bird on a wire, because now your whole boat is at 120. The challenge is the 120 going in the water. And that's where if you're in a port that has a lot of fresh water, which is not highly conductive, right? So if you're in a marina that is salt water only and no fresh water, then the electricity is going to go through salt water versus a person. But if you're in a marina that has a lot of fresh water going in, fresh water is not conductive, but human beings are more conductive than fresh water. And that's where the kids get electrocuted and die, and they drown. So those are pretty somber, but that's literally what happened to an instructor of ABYC down in Portland. He lost his son like that, almost lost his wife. Another kid almost drowned, but his kid did drown. And it was because of this situation. Reverse polarity combined with a neutral ground tie on a boat. And every household electrician that would come and wire your boat would think that the two would be together, because that's what they do in homes. And again, they can't be bothered to read a manual, so it's not their fault. Honestly, I don't blame them. It's just the world is more complicated than we think it is. So reverse polarity is a really big deal. So if you see a reverse polarity light, and you brought that up, you should freak out. Now in your case, it's not a reverse polarity, it's a floating ground, right? But if you're in a marina that is sort of not a top-notch marina, and it's sort of in the middle of nowhere, reverse polarity is a real threat.
So you just unplug right away?
Oh yeah, you're done, and then pretend you're not there. Like, just get over it. You're not at that marina. You just move on. Question is, if I turn off this breaker, would it disable the power? Like, am I going to disconnect? Not on all boats, and that's why the code is double. They need, that's the hot and that's the neutral. Some boats, like my Catalina from 1990, had a single pole on the hot only. So you would literally have your whole boat energized, and you'd stop the current from leaving. Double pole is you lock the front door and the back door. Single pole is you can come in the house, but I'm not going to let you leave the house by the other door. Hence why double pole is absolutely essential. Because if you have a reverse polarity and you have a single pole and you only have a pole on the hot, then your whole boat is energized, you're done, it doesn't matter. The robber's in the house, he's just not leaving the front door. The question is there another way of checking if you have reverse polarity if you don't have it on the panel? Some cords are going to have it actually on the cord itself, like some, like new adapters. They're going to actually show it on the shore power cord. This is a light. This takes less than, if I did on my boat, it's minutes to install a reverse polarity light. Minutes. You have to have the right light, drill a hole, connect it. But by the time it's done, half an hour and it's done. There's no reason to not have a reverse polarity light. And especially places like this, in the state, it would be criminal. The liability would be so intense, you'd lose everything. They'd probably go after your in-laws. They'd go like you're done. Like litigation in the States is so intense, there's no way you're going to encounter that in the United States. It's a big deal. They really worry about that because they'll take more than just your house, right? But in Canada, people are a little bit more lax, right? I encounter marinas that have reverse polarity. It's not uncommon. It's not uncommon. It happens. But that's one failure. And then you have to have the other failure, which is about 10% of us have. So it's like a 10 gun chamber, right? First you got to have the bullet, and then hopefully you're not one of the 10. And if you're one of the 10, then you're screwed. There is absolutely, and I see this all the time, and I can't emphasize enough, especially on AC panels, whenever you're doing, maybe some of you are going to try to work on your AC panel. No harm there. It's like on a house, right? And nobody's stopping you from working on your boat. The boat is the Wild West. Good. That's the good news and the bad news, right? Goes both ways. The love of God, please don't wire your whole boat like with one color, or randomly assign colors depending on your personal preference, right? Yeah, so I've seen AC panels where certainly, it's disconcerting. We did a job recently, it was a huge job, almost 3 weeks of work. And at my labor rate, 3 weeks of work is a lot of money. The only thing we did on that boat was fixing the MacGyver job that was done by the previous owner. 3 weeks of work, and I didn't touch the whole boat. I just started the journey. 3 weeks. 3 weeks of insanity. And a lot of it had to do with a lot of stuff like that. Just get it done, use one wire for everything. Context driven, I always know that I'm driving on that side of the road, so you should know not to drive on the left side of the road. That's my rules, so you should adapt. And then it makes it absolutely impossible for people to reverse engineer what they've done because there's no rhyme or reason. It's random. So it's very important to follow the code and the colors because then it makes things predictable, right? Like we all drive on the right side of the road here in North America, right? Because it's predictable. I always know that incoming traffic is going to be on my left. But the road, you could drive on the left or the right. It's just then unpredictable, right? And then you got to drive and you got to be like, game on. This is like Mad Max. And that's what happens when people don't follow the code is then either owners or technicians, then you end up slowing like this. You're like, oh my God, am I going to die? All the time because you don't know what you're encountering. So this is what an AC panel looks like. Pretty complicated everything, but that's basically what it is. And honestly, AC is probably the most simple thing on a boat there is. There's nothing more simple than an AC system on a boat. That's it. It doesn't get easier than that. It's pretty predictable and very modular, but that's what an AC system looks like. Again, we talked a little bit about this, the conceptual diagram. When you're adding panels on your boat, I want to emphasize this because all of us over time are going to be adding stuff. And you see this all the time when we're doing electrical audits. And you look back and you're like, how did we get here? Well, we didn't get here at once. It was always one more, oh, just another one. Oh, I'll do this, I'll do that. And then eventually you get to a point where you're like, I need another panel. Like it's not enough. Like all my 20 circuits are not switched. Like everything's always energized. And you end up adding panels or sub panels. We do that a lot now, right? Where they have a boat and then we'll add another panel to add more breakers. What you always want to do when you're either working with a panel or it's always doing a lot more than you think. If you need 4, do at least 8. I often do 4, we'll put a 12 in because I anticipate growth. We're always adding more stuff on a boat. Never just do what you need, anticipate growth, okay? And the big thing too is, so that's the spare breakers and the DC metering right here, right? If you've got a battery monitor, voltage here is really good for troubleshooting the difference between voltage at the panel, like measuring heart rate here versus heart rate here. It's better to have voltage at both places, because if you've got it at the battery on your battery monitor, I'd love to see what battery voltage is at the panel, because for troubleshooting it's great. I got battery voltage at the battery, but none at the panel. I know it's not a battery problem. It's a distribution problem. Why? Switches, fuses, you can chase it. If you only have one reading, then it's hard. So metering at the panel is always essential. You see how they have source selector switches here? 1, 2, 3. You might have engine battery, genset battery, and thruster battery, or house battery, depends. Pretty rare that we end up changing panels, but sometimes you're left with no other choice. Like we'll do that. Some boat, at one point you're like, I can't work with this anymore. Like my panel has been outgrown by the loads on my boat, and so we'll end up changing stuff on the boat, and we'll end up putting new panels on. But labeling is super important, right? Super important. Making sure you size the right breaker, not undersiding the DC feed wire, right? A lot of times what we've seen is even on my Catalina, it used to be a gauge 10 wire feeding the panel, but gauge 10 is only 30 amps, excluding voltage drop. And then you start adding radar, water pumps, all these different things. And then unrelated, your voltage is terrible at the panel, and things start breaking out, and then people are like, I can't use the panel anymore. My previous owner wired the fridge back to the batteries. Why? Because the panel was unreliable. When it would turn on, a 5 amp load would cause a voltage drop so high that the panel would drop the voltage and the fridge would stop working. So then you end up taking shortcuts, right? And so it's really important sometimes as we add more and more stuff on a boat to really worry about that feed wire so that it can handle all those loads. And these are other things that you want to have, like how many times of us have opened a DC panel and it's not enough accessibility for us to actually even open the panel, right? The wires are so short, you're looking at it. Make sure that you can actually not just close it, but open it again, right? Indicator lights. It's funny, I had another technician, well actually not a technician, but a client, he was an electrician, and he was telling me he always knew if the technicians that worked for him as electricians were good or not based on their neatness. And that's a really good sign for electricians. If you're not organized and you don't care about your workmanship, generally that means you're not detail oriented, and if you're not detail oriented, you shouldn't be an electrician. I've never, except once in my life, have ever seen something badly installed that was neat. Only once. One boat once. Every time that I've been on a boat where it failed, it looked like chaos and it was bad. I've only been on one boat where it looked perfect and it was a problem. Because that person is always worried about details. Everything sort of bothers them. You got to deeply disconnect everything, label everything. The wires are not going to be long enough. You bring the distribution blocks. You take the distribution blocks, bring them back to the circuits. That's how all the boats are built now. There's no more boat almost that is built. Even Beneteau does it like that again. Jeannot, they all do it. They'll bring all the circuits to sort of a point in the back of the panel where the circuits are terminated, and then they'll take from that point to the panel. So you have junction points. That's the cleanest way to do it. Like Grand Banks does it like that. Like North Pacific does it like that. Fleming does it like that. Northaven does it like that. I did it on my Catalina when I changed my panel. I went, okay, everything I'm going to go, like what are the builders doing? I mean, the builders are avoiding pain. They want their boats to be reliable. And so we end up putting literally distribution in the back. All the circuits go on the distribution, and they were long enough to get to the distribution, those bus bars. And then from there, then there's terminal strips, and then I take new pigtails and I bring them to the panel. And when I drop my panel now, I can have my panel all the way down. Like I'm not looking through a crack going, oh, I can't see, because all the previous owners were always making the wires too short. The wire's not long enough, oh, well, that's tomorrow's problem. And then you can't open the panel. You got to undo a connection to drop the panel further, and then undo another connection to bring it down further, and then it just becomes a nightmare. Yeah. Sometimes it's worth doing, right? Because the panel is the heart. It's not the heart, but it's the nervous system of your electrical system. This is what a nice panel would look like. That's a retrofit that we did on a boat. But that's love, right? I mean, it's love. It takes time. Right? And that's where those terminal strips are, right? Everything is terminated, right? So all the existing wire got terminated here, all labeled on both sides, and then new pigtails are coming in, and there's drip loops, and it makes a difference. Notice this is a shore power receptacle, right? If you have a generator or not, doesn't matter. The galvanic isolator is installed on the grounding connection, right? That green wire on your shore power receptacle. And notice how I'm installing it really, really close to the shore power receptacle. That device stops stray DC current from going over an AC grounding connection, okay? And what it does is it protects you for about, I think about 2 volts of stray DC current happening over your AC grounding connection. That device is not expensive. It's worth every penny. You can buy them as fail-safe. There's no single reason why a boat shouldn't have one other than frugality or costs. But honestly, this is not an isolation transformer. In Canada, something like that, fail-safe is about $400, $450 for this device. This will save your underwater metals. Even as a sailor, you might have an expensive prop or not. Some props are pretty expensive. Your propeller shaft, your strut, all those things, if ever there's a bad boat beside you, you could have the perfect boat. The perfect boat. And you have a bad neighbor, or that neighbor doesn't even know it's bad. Some people love their boats too. They love their boat and something happened on their boat. It's an accident. And the 2 boats, there could be a difference in potential, and it's possible for your boat to be used by that boat to go back to shore. And that can be really, really serious. Very, very serious. And you want a device to protect yourself in a marina. There's a lot of marinas that are hot. You use that word. It's common. And those are expensive bills. Very expensive. It takes a long time to fix. You know, you got to haul the boat out again. It's measured in weeks and months. It's not going to turn around. It's not going to be a day. And then you can really affect your boating season. So galvanic isolators are great devices, but here's the tip. You actually have to have it installed near, and nothing, again, like the shunt, can bypass this device. If you install it at the panel, like you see a lot of people do, because they're like, oh, it's beside the panel, what does it matter? What they don't realize is, and it ends up being bypassed. And if it's bypassed, it's ineffective, it's useless, it's a waste of time and money. So it needs to be a choke point, and that's why we always install them, and the code is to always install them as close to the AC shore power receptacle as possible so that nothing can ever bypass that. So reduce stray low DC currents on shore power. And it's to protect your underwater metals. Stray current. Not like, you remember how dissimilar metals underwater? I mean, even if you're in the middle of the Pacific Ocean, just floating. If you've got an underwater stainless steel propeller shaft and you've got a bronze, propeller, yeah, you need a zinc. One of them is going to go. They're dissimilar metals and they're connected, but that's a slow thing, right? Like I change my zincs once a year, once every 6 months, once every 2 years. But when you have straight current corrosion, the damage can happen in a month, 2 months. So your zincs were great before, but then suddenly they're gone because they're not just protecting your boat, they're protecting other boats. And they get chewed through right away, okay? When you buy one, you basically buy one with the different amperage, either 50 or 30 amps, and you want to make sure you get a fail-safe one. Meaning if something inside ever gets damaged, it's still going to be a wire. They used to be open. They would not be a wire, and then you'd go back to what I was joking around, like Edison days of electricity, 2 wires. And so that's why it's essential to get a fail-safe one. They call them ProSafe FS30s, okay? And basically that's what it is. You see that little Newmar? It's again, same idea. So you buy them in either 30 amp or 40. And if you have multiple shore power outlets, you're going to have multiple of those. So like I did at Grand Banks recently, a bunch of one at the fore, one at the aft, we put 2. Question is, Jeff, I have a boat in a marina. I haul out my boat every year and my zincs are in a good condition. Do I need one of these? And the problem is that the past is not an indication of the future. This device does not protect your boat against dissimilar metals on your boat that have a natural corrosion. You're not protecting. This will, if you didn't have a zinc, for example, on your boat, this doesn't protect your boat from the normal corrosion that happens there. You're protecting against outside influences. So the challenge is saying, well, I didn't have a problem last year, that means I won't have a problem in the future. The problems are not related to your boat, it's the boats in your area. So like, for example, 2 years ago, there was a marina downtown that there was like a dozen boats. Some of them were like crazy damage, like $50,000, $70,000 worth of damage from one boat that went rogue. And that owner was not a bad owner. It was a very good owner, paid his bills, did great work, nothing wrong with it, but it affected multiple boats around it. There is a device that basically disconnects the battery. It's a low voltage disconnect battery switch. And it says, when it senses too low of a battery voltage, it says, you know what, screw it. You don't have any more battery voltage. I'm disconnecting. And it's a battery switch that disconnects the batteries, or not the batteries, loads on the batteries, but it's like not for 300 or 400 amps. It's like 50 amp circuit. So there's nothing to disconnect an inverter from batteries other than you not enabling either having a low voltage disconnect, enabling that on the inverter charger. You can do that, saying at 12 volts, I want you to disconnect the inverter. You can have that, or you disable the inverter yourself, but there's no device in between the batteries and the inverter charger. Question is, I don't have a reverse polarity light on my boat, but I have an isolation transformer. Okay, first of all, isolation transformers are perfect. There is no downside to an isolation transformer other than weight, cost, and space. Every boat wants one, every single boat, other than those three factors. When you have an isolation transformer, it doesn't matter what happens at the shore. Never. Polarity is irrelevant on your boat.
It's giving the same protection.
Well, it's not the protection. It's beyond that. It's like you have Superman on the inside of your shore power. Like you're completely immune to it. You're immune to both polarity and straight current. It's Superman at your shore power. All boats that have a lot of crazy amount of underwater metals, like sea rays, stuff like that, like have a lot of stuff, it's a box that's guaranteed. It's not even an option. They all have it. Any boat that's expensive has an isolation transformer. You don't even have to tell me your boat. I know your boat's expensive. There's no other way, because an isolation transformer is a couple grand, $3,000. It weighs 250 pounds. It's this big. Everybody wants one. I want one. Well, where am I going to put it on my boat? 250 pounds on a sailboat? Where's the space? And can I afford one? And my underwater metals are not that expensive. But if you've got a power boat, like Northovens, Selines, like all those boats, any big boat, guaranteed is going to have an isolation transformer. And then reverse polarity is irrelevant. You could plug in every marina that is reverse polarity. They fix the polarity on the isolation transformer. And on top of it, straight current corrosion, you're completely immune. The only problems you'll ever have on your boat with corrosion are the ones you're going to cause inside your boat. Hence, everybody wants one. But weight, cost, and space.